Let's talk about your security stack. You have a firewall, a SIEM, a VPN. Each one has its job to do. But they all start working after a device is already connected to your network. And that leaves an enforcement gap right at the first point of entry, Layer 2. So in this explainer, we're going to dive into how Network Access Control, or NAC, closes that gap. We'll see how it acts as the enforcement layer for the security tools you already use.
Okay, so here's our plan. We'll start by defining that enforcement gap. Then, we'll look at 3 common production problems that this approach solves. After that, we'll get into how these integrations actually work using standard protocols. From there, we'll compare 5 major NAC platforms, and we'll wrap it all up with a cost and operational summary.
All right, first up, the Layer 2 enforcement gap. To really get this, we have to start with a basic question. Where are your security tools actually operating?
So let's break down where these tools live. Your next-generation firewall operates at layers 3 through 7, which is post-routing. A SIEM is an alerting system working from log data. Your VPN gateway secures the tunnel at layer 3, and DNS security, well, it works at the DNS layer. So as you can see, only NAC is built to enforce policy at that initial connection point, right at layer 2.
Okay, so we've identified this architectural gap. Now let's connect it to the real world. We're going to look at 3 common production problems that stem directly from this lack of layer 2 enforcement.
First is a problem called user ID drift, something you see in environments with Palo Alto firewalls. The firewall's policy engine needs an accurate IP to user mapping to work. But what happens when DHCP gives a new device an IP address that was just used by someone else? The firewall might still have the old, stale mapping in its table, and for that window of time, it's applying the wrong user's policy to the new device. The NAC solution provides the real-time data. By monitoring ART broadcasts at layer 2, the NAC sensor sees every IP to MAC change as it happens. It then feeds that updated data directly to Palo Alto through an XML API.
The second problem is detection without enforcement. So your SIEM generates an alert, your DNS platform blocks a malicious query. These are detection events. They tell you something is wrong, but they don't actually isolate the device at layer 2. This means that device could still move laterally within its own subnet. The NAC solution is to receive that signal from the SIEM or DNS platform. The NAC sensor, which is in the same broadcast domain, can then step in and isolate that device at layer 2.
And the third problem is the VPN compliance gap. A VPN authenticates the user, but it doesn't typically check the security posture of the endpoint device itself. Is it patched? Does it have the right security software running? The NAC solution integrates into this process. You configure the VPN gateway to use the NAC's built-in radius server. This lets the NAC perform a compliance check on the endpoint and feed that result back to the gateway, which then grants or denies access based on that real-time posture data.
So how does all this communication actually work? That brings us to section 3, where we'll look at integration using standard protocols. The focus here is on how this data flows between systems without needing proprietary connectors.
The source material documents 7 specific examples. These include integrations with Cisco VPN, Infoblox DDI, FireEye, Palo Alto for both SSO and threat response, Cisco ISE, and Genian NAC.
And this table shows the mechanisms. The integrations are built on standard protocols. Radius is used for the VPN authentication and compliance. Syslog is used to take in threat events from systems like FireEye and Palo Alto. An outbound XML API sends user ID data to Palo Alto, and a REST API can be used for other event-driven automation. The point is, no proprietary SDKs are required for these integrations to work.
Now let's move on to section 4 and do a platform comparison. We'll look at 5 different NAC platforms, specifically at their integration architecture, operational costs, and vendor ecosystems.
First is Cisco ISE. Its integration channel is called PXGrid, and it requires third-party vendors to implement a proprietary SDK. There are 2 operational facts to note here. First, PXGrid 1.0 is not supported in ISE version 3.1 and later, a change that broke some existing integrations. Second, using PXGrid Cloud requires the Cisco ISE Advantage license.
Next up, Aruba ClearPass. Its integration hub is ClearPass Exchange, which has 150 documented integrations and is included in the Access license. The operational fact from HPE's documentation is that an upgrade to version 6.11 requires all license keys to be reapplied manually.
Third is FortiNAC. It offers native integration for products within the Fortinet security fabric. For systems that are not Fortinet products, it uses standard protocols like REST API and Syslog. An operational fact here. A license update requires a radius service restart, which will interrupt authentications during that process.
Fourth on the list is Forescout, which uses a framework of integration modules called iExtend. There are two operational facts. First, iExtend Connect is licensed separately as a term license. Second, according to Forescout's GitHub, any community-developed Connect apps are not supported by Forescout's customer support team.
Okay, this brings us to our final section, a side-by-side cost and operational summary, putting all the data we just covered into one place.
This table consolidates the comparison across a few key areas. First, the integration channel. Cisco ISE uses its proprietary PixGrid SDK. ClearPass has its Exchange, FortiNAC has the Security Fabric, and Forescout uses iExtend modules. Genian NAC, in contrast, uses standard protocols. Second is cost. Both ISE's PixGrid Cloud and Forescout's iExtend Connect require a separate, premium license. The other platforms include this capability in their base license. And finally, operational risk. For ISE, an upgrade broke PixGrid 1.0 integrations. For ClearPass, a specific version upgrade requires you to manually reapply all your license keys.
So, to summarize the Genian NAC model presented here, integration relies on standard protocols like REST and syslog. This means no proprietary SDK is required, and there is no per-integration module cost. All the integration capabilities are included in the base Enterprise Edition license. This allows any system that supports these protocols to be integrated. The trade-off is that you don't have a pre-built catalog of modules. Each integration requires manual configuration based on the admin guide.
This leaves us with one final question for you to consider. Looking at your own environment, is your enforcement layer operating where your devices actually connect?